Okay, so this is going to be the second video for Algebra 2, Unit 3, Day 5. In it, all we're going to do is talk about um, basically just how to determine uh, if the inverse of a function is itself a function. And to do that, we're going to review a little bit two concepts, namely line tests, right, vertical and horizontal, and also review what it means for a function to be one to one, but that should be relatively fresh in our brains. So, anyway, so looking at these three functions, h, k, and m, we see h is a cubic function, k is a cube root function, m is a quadratic function. Okay, so let's look at h, right? So let's find its inverse. So to find its inverse, pretty simple stuff. What we're going to do, so we're going to flip the variables and then resolve. So we're going to say x equals 64 times h plus 1, all cubed. We're going to divide by 64. Take the cube root. Okay, and we can simplify here. So I can go ahead and say that this is going to become 1/4 times the cube root of x, right? And if you got lost on that, obviously come and talk to me about it. And then I'm going to subtract 1. So I'm going to do minus 1 now that I took care of the cube root. So skipping some steps here. What's more important here is just seeing the geometry behind everything. Okay, so h inverse equals 1/4 all times the cube root of x, all of that minus 1. Okay, so let's graph that really quick and see what we've got. Okay, so let me pull up my Desmos stuff here. And let's see, let's make it not so giant. How about we do that? Desmos has got to get more user friendly in this regard. Okay, so I'm going to enter in both of them. So the original function, if I can see, the original function was 64 times x plus 1's all cubed. Okay, so that looks insane. And then we have, so I'm going to put 0.25 just to shorten, CBRT all minus 1. And then just to prove that these two are inverses. Okay, so here we have it. Let's go ahead and make this larger. So we see the very clear symmetry, right? And the question is the inverse, so this guy right here in blue, is the inverse itself a function the same way that what it came from here in green, right? What it came from was also a function. So obviously 64 times x plus 1 all cubed, that's a function. But is its inverse also a function? So the easy way to tell is the vertical line test, right? So if I just do this, oh, it's doing that thing where it doesn't let me make a slider anymore, which is infuriating. But let's say y equals 5. Okay, so now it's going to let me make a slider because it's stupid. Okay, so does it pass the horizontal and vertical line tests, right? So let's go ahead and um, mess with this a little bit. So first, let's start with the vertical line test. Okay, so both functions pass the vertical line test. We see this vertical line here does not intersect either function more than once. Okay, so that's good. That means they're both functions. Now, a way to tell without even having calculated the inverse, a way to tell is to do the horizontal line function. Well, why would that be? Well, because if it passes the horizontal line function, then that means that it's one to one. So when we turn it on its side, like we do here, right? If it's one to one, when we turn it on its side, well, when we change that horizontal line into a vertical line, it's still going to only intersect it once. Okay. So let's look at, I'm not going to waste too much time in this video. I think you'll be all right without seeing number two as an example. Uh, this is going to be a much more pertinent example. So let's go ahead and calculate m inverse. So x is equal to m squared minus 1. So add 1 and then take the square root. But we have to remember, when we take a square root, it's always plus or minus. So that would be m inverse. So m inverse is equal to plus or minus the square root of x plus 1. Okay, so let's see what all that looks like. So let's go back to our graph here. That is not the right page that I meant to click on. Where is my graph? I like how it just disappeared and I can't find it now. It's going to be funny though if I look back at the video and I actually just closed it instead of like minimizing it. Okay, so x squared plus 1. No, it was minus 1. And then we have square root of x plus 1 and negative of that. X minus 1 plus 1. Okay. So there we have plus or minus for its inverse. And again, we see the clear symmetry here, right? It's exactly symmetrical the way it's supposed to be. So that tells us that they are in fact inverses. Right now, let's talk about vertical and horizontal line tests. So I'm going to erase my inverse for a minute here. And I'm going to input, so what does this guy want me to put? Oh, x equals 5. Okay, so I have to do that to pull up a slider. So does it pass the vertical line test? Yes. So obviously x squared minus 1, that is a function. Okay. Now let's talk about, however, the horizontal line test. So does it pass the horizontal line test? And the answer is no. It does not pass the horizontal line test. This tells us that this parabola, which we already knew, is not one-to-one. We do not have a unique element of y for every element of x. Okay, so it's not one-to-one. So what does that mean, you might be wondering? Well, let's bring the inverse back up. Let's bring the inverse back up. So right now it passes the vertical line test before we translate it into its inverse, right? So when I bring up the inverse, does it pass the vertical line? And the answer is no. And that goes back to what I showed you earlier. Because it was not one-to-one, it didn't pass the horizontal line test. So when we lay it down on its side, when it's an inverse, uh, that vertical line, or rather that horizontal line becomes vertical and it still applies and shows us that it is not a function. Okay, so as quickly as I automatically close that page, I'm pretty sure that's what happened earlier. So is there a way to tell a function's inverse is also a function without the math? Yes. Okay, all we have to do is look at the original function, check to see if it's one-to-one. If it is one-to-one, its inverse is also a function. If it is not one-to-one, meaning it fails the horizontal line test, then that means its inverse is not a function. Okay, so that does it for this video. Like always, you guys know where to find me. Goodbye.